All right, we're in section 12.3 where we're going to look at surface area of pyramids and cones. So what we have here on each side of the screen. So on the left-hand side is an example of a pyramid. So a pyramid, it has a base that is a polygon, and then it has a series of triangles that meet at a vertex. On the right, we have a cone, which is similar to a pyramid. It goes to a point, but the base is a circle. So mainly what we have is we have two, oh, and the big difference is they both have, one's a polygon, one's a circle for a base. The other one is there, it's a series of triangles that connects to the vertex of a pyramid. When it comes to a cone, there is no triangles. It's just a circular piece that is, and then eventually connects to a vertex. So those are the main differences, but it has two main components that we're trying to look for. We're trying to look for where the vertex is, and we're also trying to look for where the slant height is on these particular objects. So first things first is they wanted us to draw a net of these particular objects. So this was what, a 1, 2, 3, 4, 5 sided figure. So if I draw that out, I got 1, 2, 3, 4, 5. And then what you're going to do is you're just going to draw triangles from there. All right. And so then that would be your net for that particular example. If I look at trying to draw the net of a cone, sometimes, or I would say a majority of you guys probably won't be able to look at it initially and be able to say, okay, I could draw this. So the hardest part is being able to draw the circular piece here that gets attached to the vertex. So here's what it looks like. It basically kind of looks like Pac-Man. So you have this shape right here, and then you got a circle around here, and then you have the base of the circle to be right here. Okay, so I know it's not to scale or anything, but essentially the distance around here is going to be the same as the distance around here, which is the circumference, which is 2 pi r, which again equals the circumference. If we're looking at this value here, this is where the slant height is located, that and this. All right, so that's how you would draw a cone. Here we have the surface areas of a regular pyramid and the surface areas of a right cone. So for surface area is equal to base, which is the area of the base, plus n, which is the number of sides the base has, times it by the area of a triangle. If you look at the cone, we got base, which is the area of a base, which is going to be a circle, which is pi r squared. And then it's going to be plus 1/2 times it by the circumference of that circle, 2 pi r, and then times it by L, which is the slant height. Okay. So what we have here is they want us to find the surface area of the pyramid or cone. So we have the pyramid here on our left. if you look, we have hash marks on the bottom of the base, so even though it doesn't look like it, it is in fact a square. So we have the area of the base. In this case, the base is going to be, we'll just put area right here. Area of the base is going to equal 10 squared. Now, n, they were telling us n is the number of sides the base has. So it has 4 sides, so n is going to equal 4. And then we're going to look at the area of each of these rectangles. It's going to be 1/2 the base. Well, each base is going to be 10. But what we don't know is we don't know what the height is. All we know is that the distance from the vertex to the bottom of the base is 12. To find the height, I actually got to find the slant height. So in order for us to find the slant height, we have a right triangle right here, which means we can use the Pythagorean theorem to solve it. So the distance from here to here is going to be 5 because it's half the distance of our square. So now I can say that 5 squared, which is 25, plus 12 squared, which is 144. So I'll just type that in. 5 squared plus 12 squared is equal to essentially c squared. So this is 25 plus 144 is equal to c squared. 169 is equal to c squared. So that means my slant height is 13 when you take the square root of both sides. So this right here is 13. So to look at the area of this particular or these particular triangles, it's going to be 1/2 times 10 times 13. So using the formula, so I got surface area is going to equal area of the base, which is 10 squared, plus n, which is 4, times it by 1/2 times the base, which is 10, times by the height in this case, which is 13. So I got 100 plus, all right, so I got 13 times 10 times 1/2 times 4, I get 260. So then this gives me 360 square feet. Okay, so looking at the cone, same idea. We got to first find the area of the base. So the area of the base is the area of a circle, so it's going to be pi r squared. Well, we got a radius of 10, so it's going to be 10 squared plus 1/2, and then c, which is the circumference of the circle, so we're going to be 2 pi times 10, and then it's going to be multiplied by L, which it said, which was the slant height. Well, the slant height is this value right here. Well, we have, again, we have a right triangle. We can solve for that. This portion that it's in question is the hypotenuse, so I can say, all right, I got 10 squared plus 24 squared is equal to c squared. I got 100 plus 24 squared is 576 equals c squared. So 676, what's the square root of 676? That gives me 26. So 26 is equal to c. So that's 26 here. So my slant height is 26. All right, with approximations, I'm going to use 3.14 as pi. So I got 10 squared, which is 100, times that by 3.14. I got 314 right here. Plus, I have 10 times 3.14, times that by 2, times that by 1/2, so, and then times that by 26. I got what, 816.4. Add that to 314, I get 1,130.4 square centimeters. And that is being able to find surface area of pyramids and cones. Hope this helps. Till next time.